All right, we're on day 2 of lesson 6. So you're going to need your lesson book, notebook, pencil. We're going to be on page 45 and 46 of your lesson book. Okay, so we're still trying to understand functions. We're going to identify whether a function is whether the relationship is a function, and we're going to look at tables, graphs, diagrams, and we're even going to talk about equations. Okay. So let's get started. So I want to explore the idea with ordered pairs. So today I want to review how we're going to graph our ordered pairs and from a table as we're discussing is this a function or not, okay? So the table shows the number of dog licenses issued in the town of Palmer over a 5-year period. On the blank graph to the right, label and number the axis, then plot the ordered pairs. Okay, so as you can see, this is our y and this is our x. Our y goes up and down, it's our vertical axis, and our x goes side to side, it is our horizontal axis. Our input always is our x value, okay? So my year is always going to go at the bottom, and my output is always my y. So in this case, our output is the number of dog licenses. Okay, so we're going up by year as 1, 2, 3, 4, 5. So what I'm going to do is I'm going to kind of stretch this out a little bit since I'm only going to 5. I'm going to go 1, 2, 3, 4, 5. And my dog licenses, I'm going up by 75. Okay, or let's just look at the output and see how we're moving. Okay, so for this one is 75, and then 2 is 100, 125, 125, and 150. So let me ask this. Am I going up by 75? Well, from here to here, how many did I go up? Good. Okay, what about from here to here? How many did I go up? Good, 25. I didn't go up at all, did I? And then, okay, so what I'm probably going to look at is going up by 25s, aren't I? So I'm going to make this one 25. I'm going to make this one 50, 75, 100, 125, 150, 175, 200. So this is how we look at it. So when we create a graph, we don't always have to go up by 1, 2, 3, 4, 5, but we have to go up consistently. So our x and our y have to be consistent as we move. So in your book, pause it, and I want to see if you can graph them without me first. So pause my video and try to graph our input and outputs. And go. 3, 2, 1. Did I give you enough time? Did you pause yourself to give yourself enough time to do this? So let's see. So 1 to 75, 2 to 100, 3 to 125, 125 for 4, and 5 gets 150. Let's look at what we have. Okay, is this a function? Do I have any dots that are on top of each other? It's kind of like saying, well, in year 3 we sold 125, and in year 3 we sold 150. I couldn't have sold the same in the year, so I want you to imagine that, so I can't sell 2 different amounts of the same item in the same year. So this would be a function. All right, so the next question, it says describe the relationship between the input and output. So what does that mean, describe the relationship? Well, it means as my years go, what's happening? So with each year, what's happening with the number of dog licenses? What do you notice? Well, Most of them, we gained 25 each year, huh? So we had 25 more from this year. We had 25 more from this year. What happened from year 3 to 4? We had the same amount, right? And then what happened from year 4 to 5? We had another 25 more dogs, right? So with each year, we're increasing almost. That would be our input, output. That would be our relationship, right? Most years we were increasing by 25. Okay, so how do you feel about this one? We feel okay? Kind of looking at reviewing a little 6th and 7th grade? Yeah, all right. So let's look at this one. This one says, dogs age faster than humans do. Some people claim that a dog years are a function of human years. As shown in the table, on the blank graph to the right, label and number the axis, and then plot the ordered pairs. So what I want you to do is I want you to pause the video and I want you to label it first, and let's see how your thinking is, okay? So pause the video and label your axes. Go. You ready? Let's see how you did. So here's my X, here's my Y. So my X is going to be the age in human. How'd you do? So of course, if you did good on that one, then I know you did good on your Y-axis, because this one is going to be the age of dog years. Okay? All right, it's hard to write sideways, but it looks okay. So let's look how my age is going up by human. 1, 2, 3, 4, 5. Hey, that's easy enough. 1, 2, 3, 4, 5. Now, do I have to skip? No, I sure don't. If you want, I can even do it smaller. I just like to stretch it out a little bit. But you could go 1, 2, 3, 4, 5. You could definitely do that. Okay, so let's look at our dog. Age and dog. 7, 14, 21, 28, 35. Hey, how is this one going up? 7, 4. Are we going up by 7s? We sure are. So guess how I'm going to go up in my Y's? I'm going to go up by 7s. 7, 14, 21, 28, and see. 1, 2, there we go, 35. Okay. So I want you to pause my video and I want you to graph it. Go. Okay. Let's see how you did. So if you look at this table, okay, and we have our X on top and our Y, I want you to be able to recognize my ordered pairs. So here's an ordered pair. Here's an ordered pair. Here's an ordered pair. Okay, I want you to be able to see your ordered pairs. They're in the table. They are right there for you. And this is how I see them as well. So when I'm graphing 1 to 7, I'm graphing my X, then my Y. X comes first, don't ask why. That's what I always say in my classroom to help us remember that we graph with our X first and then our Y. So 3, 21, 4, 28, 5, 35. And look what we have here. We have a straight line. Isn't that awesome? And we will get to lesson 8 where we get to talk about what a linear function is. Okay? But I'm going to go ahead and start using that word now because linear means line, and this is exactly what we have. So can we describe this relationship? What is happening every age for human? What's happening with our dog years? Pause my video and see if you can put into words number 5, which is to describe this relationship. Pause my video, go. Okay, you all ready to discuss? So, how are my inputs and outputs related? Did you say that with each 1 year, that the dog has 7 years? With each 1 year is 7 more dog years. So, that's right. So good job on that. If and if we look here, this one is almost that way, huh? See how this one is almost a straight line, but it's not. Okay, so now we're going to turn the, well, y'all aren't going to turn it. We're going to look at the next page side by side. And number 6 says, the relationships on the previous page, that's why I'm showing them like this. Which graph or graphs show exactly one output for each input? Which graph or graphs show exactly one output for each input? One output for each input. Well, they both do, don't they? Yeah, and so which set or sets of data represents a function? Do they both represent functions? Absolutely. Do each input have one output? Yes. Okay. So good job on that one. Okay, so let's look at number 7. It says, think about the function related to the dog licenses. Would there ever be 1 year that is assigned to 2 different quantities? We've been talking about this, haven't we? Can I have 1 year where I have 2 quantities? So let's say year 3 and 4 have the same licenses. But what I'm asking is if I had 2 of this, so year 3 and year 3, I have 125 and I also have 150. Why wouldn't that work? So write down in your notebook, could there ever be a year that is assigned to 2 different quantities? Pause my video. 3, 2, 1. So what'd you come up with? Did you say that it wouldn't make sense to have 2 separate quantities? That why wouldn't I just add them together and get one quantity? Because if I want to know the total of dog licenses, yeah, so that's why it would not make sense. I want a total. I wouldn't have 2 totals in the same, that wouldn't make sense. Why would, yes, so good job. Okay, so number 8 says, look at the problems 3 and 5. Can either functions, could I write an equation for them? So let's think about number 3. Is my relationship on number 3, is it a consistent relationship? Does it move up the same each time? It almost does, doesn't it? 25, 25 doesn't move, and then 25. Could I have an equation for that one? I can't, can I? Why not? Is it consistent enough? Does it go up the same every time? Well, right here it didn't, did it? That's why my equation wouldn't work. Well, let's look at number 5. Could I draw an equation for this one? Is it consistent every single time? Yeah, it is. How are we moving each time? So I'm going to let you pause my video, and I want you to go back to 7th grade, and I want you to think of your proportional relationships and trying to write an equation using your rate of change and your constant, and see if you can come up with your equation. So pause my video and see what kind of equation you can come up with. Go. 3, 2, 1. Let's see how you did. So let's go ahead and make this screen bigger. And let's see how we're moving. How am I going from 1 to 7? We could say plus 6, but we could also say times 7. Okay, so let's see which one is the same for the next one. 2 to 14. Well, 2 plus 6 is not 14, so we rule this one out. 2 times 7 is 14. Let's do another one. What's 3 times 7? 21. 4 times 7? 28. Awesome. Okay, did you say it was times 7? Good. I'm glad you did. So if it's times 7, how would that look as an equation? Well, first of all, I want my equation to always equal y, but I'll let you write it backwards and then we'll rewrite it. So I know that we're going to be multiplying by our 7 and we're going to be multiplying our x. So when I multiply a number by a variable, they're side by side. So this is what you might have wrote down, but we're going to flip-flop it. I want my y to come first because I want my function to always represent my y. So we're going to do y equals 7x. Okay, so let's try another way. So now I'm giving you the equation, and I want you to go ahead and fill in my outputs. So pause my video and go ahead and do number 9. And go. 3, 2, 1. Let's see how you did. So notice my y is first because that's my function. It's what it is. And so it's the output of my function. My function is x plus 2, and my answers are going to be my output. So let's see how you did. So x plus 2. So negative 2 plus 2 is 0. And then negative 1 plus 2 is 1. And then 2. And then 2 plus 2 is 3. All right, how'd you do? So the second one says, state whether it represents a function. Does this represent a function? Absolutely. Good job. And why? Because each output has one input. Okay? Good job. So pause my video and let's do number 10 and see how this looks different. Pause my video and complete y equals 4x. Go. 3, 2, 1. Let's see how you did. So now what operation is that? We're multiplying, aren't we? Yes, we are. So a negative 2 times 4 gives you a negative 8. How'd you do? Yeah? Okay, if you caught your mistake from negatives and positives like you did with number 9, go ahead and pause it and fix them. Okay? So this one should be negative 4. 0 times 4 is 0. 1 times 4 is 4, and 2 times 4 is 8. How do we do? This one goes up faster, doesn't it? It's not just a 1, 2, 3. Why do you think it goes up faster? Did you say because we're multiplying instead of adding? Good. Okay, so again, is this a function? Explain. Did you say that it was a function because my x's do not repeat? Good job. Today, y'all finished. This is day 2 of lesson 6. Understanding what a function is, and that a function doesn't always have to be a straight line. But my x's, I cannot have repeating x's. Okay, so good job today, guys. Okay, till I see you next time in lesson 7. Bye.